In our previous video, we were using the normal distribution to figure out the probability that x was less than, greater than, or in between certain numbers. So you'll recall, just scroll back a second here, we looked at what's the probability a foreman will make less than 775, more than 1225, or in between 900 and 1225. And we looked at how to use the standard normal table to do that, and we looked at how to do that in Excel. Well, what if you already know the probability and you want to find the other number? What if you want to find that particular event or outcome? So, for example, suppose that we have a normal distribution. So that's what this is telling us here, that x has a normal distribution with mean 11 and standard deviation 2. That's what this notation means here. So, what is x if the probability is 2.5%? So if you think about this here, we're saying, okay, well, we want to know this number here where this area that's less than is equal to 2.5%. Okay, so we're saying, okay, can you find this? Well, how would we go about doing that? Well, if we're doing that by hand with our standard normal table, we're going to have to reverse engineer from our z-score table. We're going to have to solve for x. Okay, so let's work at how to do that. All right, let's go to our standard normal table. We're doing everything to the left, and we're looking for a number that is 0.025. So we're looking inside the table now, and we're looking inside the table for 0.025. So here we have 0.00. We want 0.0. So keep going. 0.022. We want 0.025. 0.024. 0.025. So here we have 0.025, and it happens at a z-score of negative 1.96. So here we have z equals negative 1.96. That had a probability, everything to the left, of 0.025. So then we need to solve for x. So x minus mu is 11, sigma is 2. We would rearrange that and solve. So how do you rearrange that? You multiply both sides by 2. You get x minus 11. And if you add 11 to both sides, so we have 2 times negative 1.96 plus 11, that will give you x. So we're rearranging the formula to solve for x. And what we would get is 2 times negative 1.96, and then we take 11 and we add that to it. We get 7.08. So in this case, 7.08 would be the x where the probability you're less than 7.08 is 2.5%. Okay. If we want to do this instead in Excel, so save us all the hassle of all this math, we can do this in Excel. Equals normal, and instead of distribution, do inverse. So we're just doing an inverse lookup here on our table by going from the inside out instead of the outside in. Here, once the probability, so 0.025, and then you need to give it the mean, which was 11, and we need to give it the standard deviation, which is 2, okay? And you can see it has solved the problem for us at 7.08. Way easier than having to look things up on a table and having to do the calculation by hand. But we can totally do it because we know how this works. So let's try this one. Probability that it's less than 0.1. So what do? We go and we look. Let's just verify 0.1. And we're looking for the number 0.1. All right, so as we look at our table here, 0.00, 0.06, we're looking for the number closest to 0.01. Right, so we got here So when you have it like this, that's halfway kind of ish in between, one thing you can do is you can go halfway in between. We can call this negative 2.325. Okay. So we have our negative 2.325. Okay. Again, we're going to have to rearrange this. So we get this is equal to x minus 11 divided by 2. So to solve for this, we would do negative 2.325 times 2 plus 11. So it's the same rearrange. Once you do it once, you have it the same. And you get 6.35. To do this in Excel automatically equals, remember it's norm, and this time it's inverse because we're doing an inverse lookup. Probability here is 0.1, mean is 11, standard deviation is 2, and did we do it right? 0.1. What was I looking up? 0.01? No, what am I? Losing my mind. Okay, we don't want 0.01, we want 0.1, which means it's not going to be, this one's the wrong number, not 0.01, we want 0.1, 0.1. So, not 0.06, we want 0.1, so in between those two is 0.1. So negative 1.2, let's try this again. Negative 1.285. Negative 1.285. So if I do that, let's go back, negative 1.285. There we go. That's why. Same number. Ugh. All right. Decimal points. They're killing you. They're killing me. All right. What if we want to know x such the probability that it's greater than is 95%? So if you're going to do this way, remember that if this is greater, you're going to have to do the switch first. So 1 minus 0.95 is 0.05. Our table in Excel give us less than. So probability that it's greater than is 0.95. The probability it's less than is 0.05. So now we need to find the z-score that goes with 0.05. Make sure we have the right number of decimal points. 0.05. 0.0505, 0.04947. This is happening at 1.645. Right, halfway in between. Negative 1.645. Negative 1.645. And that is going to be equal to x minus 11 divided by 2. So we're, of course, going to multiply that. Negative 1.645 times 2 plus 11, 14.29. And alternatively, we do equals norm dot inverse. And the probability we want here is 0.05 because, again, Excel is also doing to the left. And 11 and 2. And you get that. How do we do? 0.05, 11 and 2. I'm going to type in inverse. Okay. And that was it. Is that right? Negative 1.645 times 2 plus 11. 7.71. Okay. Too many numbers. Can't keep them all track. All right. So we get 7.71. So you can do it in Excel, you can do it by hand, but it is, sometimes you will need to find the value when you already know the probability. So all of this is building towards, as we get to our inferential statistics, looking at comparing the probability, the area under the standard normal distribution that we get from our comparing our sample to that probability distribution for the greater population to see, is there a statistically significant difference? So that's where all this is going, and we'll get to that in a video, in an upcoming video.